Good morning. Now I am going to explain detectors in HPLC. In HPLC. Detectors in HPLC. So first detector is a SUV detector. One of the most important detector is a UV detector. So here UV detector mainly here any compound could interact with the electromagnetic radiation, electromagnetic radiation. The beam of electromagnetic radiation passes through the detector closure will experience some change in the intensity in outcoming light. So this some of the light is interact with the matter, and this measures changes the wavelength of the radiation. Outcoming radiation wavelength is changes. This is a basic principle of the most of the optical detectors, optical HPLC detector. So here radiation observance, the sample mainly depends on the yes the radiation wavelength and functional groups of the chemical compound. The radiation wavelength and functional groups of the chemical compound. There are generally three major regions are used in the spectroscopy. So that is in liquid chromatography, in IR spectroscopy, meters have found only limited use. Yes, spectrometers working in the range only 200 to 600 nanometer in the visible region, UV visible region. But UV region is a is mainly 200 nanometers to 800 nanometers. But spectrophotometers are working only 200 to 600 nanometers. So these are mainly used widely used in the S liquid chromatography detectors. The majority of organic compounds can be analyzed by UV visible detectors. UV visible detectors. Almost 70% of the compounds are analyzed by HPLC technique. In HPLC technique by using the UV detectors. UV detectors. So UV detectors. First one, UV. So UV detector. So in chemical compound, chemical compound interacts, would interact, would interact electromagnetic radiation, electromagnetic field or electromagnetic radiation. So electromagnetic radiation, beam of electromagnetic radiation. EMR means electromagnetic radiation. Beam of electromagnetic radiation passes through the sample, passes through the sample, passes through the sample, sample containing detector, sample containing detector. So the yeah, during flow, so some change in some change in some change in the in its some change in its intensity intensity due to this intensity due to this interaction of due to this interaction of EMR with detector containing matter containing detector containing compound. This measurement changes on the these measurements of the air radiation, the incoming intensity and outgoing intensity is somewhat different. Outcoming transmitted light radiation somewhat different. So this changes is the basis for the most of the optical HPLC detector. UV visible spectroscope is the one of the optical HPLC detector. So this is the UV detector is a optical HPLC detector. So then what happened? Here change in measurement here. What happened due to interaction of the compound? There is a measurement of the this is a measurement of this changes is the basis of the most of the optical HPLC detector. So here mainly radiation here radiation depends on radiation absorbance radiation absorbance depends on the depends on the radiation wavelength and functional groups of the chemical compound. So radiation absorbance depends on the radiation wavelength radiation wavelength radiation wavelength and functional group functional group functional group present in chemical compound. Chemical compound. So here radiation wavelength mainly using in the here which region? Here UV visible region that is a 200 to 800 nanometers. So we are using 200 nanometer, 300 nanometer. That is a variation. And also functional groups. Functional group nothing but the different functional groups is present in the organic molecule. Halides, ketones, esters, samides, nitro, alcohol, etc. So many functional groups. So the absorption radiation mainly depending on the air used wavelength or used radiation as well as the nature of the chemical function, nature of the chemical compound, nothing but the different functional groups observing the different radiation. So majority of organic compounds, major region of the organic compounds observes the 200 to 800 nanometers or 200 to 600 nanometers. So most of the visible spectroscopy compounds here 70% is analyzed by using HPLC UV visible detector. So 70% of organic compounds organic compounds compounds analysis analyzed by using UV detector. UV detector. So UV detector is the most preferable detector in the HPLC instrumentation. So this is about the UV visible detector. Next to photodiode array detector. Second one, photodiode array detector, photodiode array detector. So here photodiode detector, it is a photo detector mainly capable of the converting light into device. So that is mainly either converted into a voltage or maybe current. So light is converted to voltage or current depending on the mode of operation. So here this is mainly photodiode. Photodiode is a type of photodetector. Is a type of photodetector. Photodetector. So here mainly here conversion of light into conversion of light into yes current current or voltage current or voltage current or voltage. This is depending on mode of operation. So when light is fall on the here photodiode is mainly conversion of the light into current and voltage, that is depending on the mode of operation. So here light conversion mainly what is the here using. So this is a photodiode photodiode. We are subjecting to light, that is a which light electromagnetic radiation containing light. So this is mainly what happens. The photodiode is a here process is mainly takes light into current current or voltage current or voltage current or voltage. So here photodiode symbol for the photodiode. So this is a symbol for photodiode. Symbol for the photodiode. So this is a here mainly this is an anode. This is a cathode. So this is a symbol for the photodiode. So this is a here mainly a construction of the photodiode array detector. This is a only just a symbol for the photodiode. Now the construction of the photodiode. So this is a photodiode detector. This is a source of radiation or light source. Source is attached to the sample. Here, this is a sample cell. This sample cell is attached to the entrance slit. So this is a here entrance slit. Entrance slit. So this is entrance slit is mainly here attached to prism. So this is a prism. So this so prism the prism. So this prism to what happen is mainly producing the monochromatic radiation. So the outcoming light is far into the device. This is a detector device. This is device is called as a diode detector. Photo diode photodiode detector. So this is a photodiode array detector construction, the cell construction. So generally, traditional solar cell, solar power producing purpose. Yes, traditional solar cell use is mainly used to generate the electrical power is a large area photodiode. Photodiodes are the similar to semiconductors, regular semiconductor diodes. Are these are the except that they may be either exposed or packaged with a window or optical fiber. So these are connection to uh, allow the light to reach the sensitive part of the devices. So many diode devices are designed used for the specially as a photodiode use a PIN junction. Nothing but the PI junction rather than the PN junction diodes. So PIN junction rather than PN junction diodes. So this is mainly, yeah, these are similar to semiconductors. Semiconductor diodes. Similar to semiconductor diodes. This current or voltage mainly, yeah, this can be detection of the our analyte. Another one more important detector, fluorescence detector. Fluorescence detector. So fluorescence detector are mostly sensitive among the existing modern HPLC detector. So this is a mostly sensitive detector, mostly sensitive detector compared to the existing modern HPLC detector. It is mainly possible to detect even presence of the single analyte molecule in the flow cell. In the single analyte molecule is single molecule, nothing but the only one molecule present in the flow cell that can be detected by the fluorescence detector. Fluorescence detector sensitivity is mainly here 100 to 10 to 1000 times is higher than that of the UV visible spectroscopy. Yes, UV visible detector compared to UV visible detector, it is a thousand times is a higher sensitivity fluorescence detector. So UV detector, yes, then generally a fluorescence detectors are the very specific and selective measurement of the specific fluorescent species in the samples. Here, roughly about 15% of the all compounds are the natural fluorescences. Yes, roughly around 50% of all the compounds have a natural fluorescence. These are presence of the conjugated AS pi bonding electrons, especially in the aromatic systems. They give mostly S fluorescent activity. They give mostly fluorescent activity. So this is a fluorescence detectors. Fluorescence is the most sensitive com, compared to existing modern compared to existing modern HPLC detectors. Modern HPLC detectors. So here mainly did even detect even 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 presence of presence of single analyte molecule presence of single analyte 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 molecule present in analyte molecule in flow cell single molecule is there that can be analyzed. So here these detectors these detectors these detectors are highly sensitive. These detectors sensitivity is 10 to 1000 times higher than higher than UV visible detector. UV detectors. UV detector. So UV detector. This is mainly detects detects very specific detects very specific and selective measurement measurement of sensitive species are specific detectors very specific selective measurement of fluorescent species fluorescent species fluorescent species fluorescent species. Okay, so here most of mostly 50 percentage of organic compounds organic compounds mostly 50 percentage of organic compounds have natural fluorescence natural fluorescent natural fluorescent natural fluorescent due to pi bonding electrons involved in conjugation involving delocalization. So involving delocalization, they are exhibiting the fluorescent nature. The fluorescence detector is the detected. Yes, detected. So example, which is the S aromatic compounds. Aromatic compounds. Benzene is naphthalene, anthracene, etc. Toluene, xylene, all are the yes aromatic compounds. These are exhibiting the yes natural fluorescence nature because they are presence of the conjugated bypass. They are involved in the localization. The conjugation effect is there. The absorption radiation also increases. Then they are giving the which is there yes fluorescent nature in the fluorescence. Therefore, this can be detected by the fluorescence detector. So here mainly fluorescence detection fluorescence intensity depending on the both the excitation and emission of the wavelength. Excitation and emission of wavelength. So here fluorescent detectors are available and market differ in the method in which the wavelengths are controlled. So less expensive instruments differ in the wavelength and medium priced units offer monochromata controller at least emission wavelength. So here one more point fluorescent fluorescent intensity depends on depends on excitation excitation and emission radiation wavelength. So the intensity is mainly depending on excited and emission radiation wavelength. This main purpose it is mostly applicable for mostly applicable for conjugated systems, conjugated molecules, conjugated molecules. Now see the plate theory. Plate theory. So plate theory. So this plate theory is nothing but the also termed as a theoretical plates of the modern chromatography. Theoretical. This model mainly is supposes that the chromatographic column is contains large number of the separated layers. Large number of the separated layers called theoretical plates. Large number of the separated layers is called theoretical plates. So these are separate equilibrations of the sample between the stationary phase and mobile phases. These theoretical plates are separated equilibrations of the sample between the stationary phase and mobile phase during the chromatographic process. So the analyte in this process, the analyte moves down from the column by transfer of equilibrated between mobile base and transfer. Here mobile base to stationary base to mobile base and mobile base from one plate to the next plate. So it is an important thing is mainly the plates do not really existing. These are just imaginary as plates. So these are the not really existing, just imaginary plates. These plates are the are pigments of the pigments of the pigments that helps us under serve as a way of measuring column efficiency. Yes, may have way of the measuring of the column efficiency, thereby the starting the number of theoretical plates in the column is a capital N and or by the starting the plate height. So the plate height equivalent of the theoretical plates can be calculated by the HETP. Height equivalence theoretical plate is equal to L by N. L nothing but the height of the column height, and n nothing but the number of theoretical plates. By using the height of the column and number of theoretical plates, we can calculate the S height equivalent theoretical plates (HETP). So the number of theoretical plates for the real column process can be found by the examining chromatographic P and after elution. So that can be in one formula n is equal to 5.5 here TR square by S TW W half square. So yes, pair theory model is chromatographic 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 column column containing large number of large number of chromatographic column containing large number of separate layers separate layers separate layers separate layers are called theoretical plates are called the theoretical plates are called theoretical plates. So theoretical plates. So these theoretical plates can be seen here. A column. This is a column. So these are the theoretical plates. So this is a called as a column. This is a theoretical plates. Nothing but the imaginary layers. Imaginary layers. So here large number of separate layers is theoretical plates. These are the separate separate equilibration of sample between mobile phase and stationary phase. Between mobile phase and stationary phase. Stationary phase, this then occurs plates. Occurs plates. Occurs these plates. So here in this case, the analyte moves down. The analyte moves down, moves down, analyte moves down the column by transfer of equilibrated by transfer of transfer of equilibrated equilibrated by transfer of equilibrated mobile phase mobile phase mobile phase from one plate to next one plate to next one plate to next. So these are not really existing theoretical plates are these are imaginary imaginary. These theoretical plates mainly measuring is by using as this is a serve as a measuring measuring serve as a measuring serve as a way of measuring way of measuring column efficiency column efficiency column efficiency serve as a measure of column efficiency. The theoretical weights serve as a measure of column efficiency, measuring column efficiency. So here the height equivalent of theoretical weight can be calculated by L by N. So L by N bar. L means N means number of theoretical. L means height of the column. Height of the column. N means number of theoretical plates. Number of theoretical plates. Number of theoretical plates. HETP is equal L by N. L means height of the column. N means number of theoretical plates. So number of theoretical plates that are real column possess can be found by examining the chromatography peak after elution. So therefore n value n can be n is equal to yes 5.55 TR square by W of square. N is equal to STR means the retention time. WR means width of the column. Here W is equal to peak width at half height. Peak width at half height. Yes. So or otherwise this can be how to written here. Yes. N is equal to 5.55 into TR by W of whole square. So as we can see in the from the equation, column behaves if have different number of plates, different solutes in a mixture. Different number of plates for a different solutes in a mixture. Thank you to all. Please take this screenshot.